Thank you for joining me again. Now, today we'll be talking about rational inequality. And under this, we will be showing the solution on a normal line. As we show it graphically, then we can also show it by intervals. Yes. So here, if we have this, how do we solve this? The first thing is we'll find the zeros of this. And that implies that we say x minus 3 when it's equal to 0. That implies that x can be equal to 3, right? So x is 3. Then we have x plus 1 is equal to 0. That implies x is equal to what? Minus 1. So we have minus 1 and 3 on the number line. We have this. We have this. We have, if our minus 1 is here, 0 should be somewhere here. Here. 1, 2, let's say we have 3 there. So here we add this to infinity, we add this to negative infinity. So what else? How many regions do we have? We have this region, we have the whole of this region, we have this region, we have this region. Right? Now let's check when these regions are positive or negative. So what do we do? Check for when these regions are positive. Let's start from this region. What are the values that will fall in this region when x is greater than 3? Between 3 and infinity. Let's check it with 4. If it's 4, if x is 4 along this region, we want to know whether it is positive or negative. So what are we going to add? From there, we have, if we pick x to be 4, that will be 4 minus 1. And minus 3. Now we want 1 over, then we put this 4 minus 3 is 4 minus 3 over 4 plus 1. That is what? 1 over 5. What about, I need the signs. So this one is positive, this one is positive. That will still be positive, right? So this region is positive. If you try 5 and more, you get this on for this region. Let's check this region. Between minus 1 and 3, what do we have? Between minus 1 and 3, what do we have? Let's consider 0. Minus 1 and 3, 0, 1, 2. Let's consider 0. When is 0, we have 0 minus 3 over 0 plus 1. That is minus 3 over 1. So we have minus 3 plus 1, and that is negative. We need the sign. Minus divided by plus is negative. This region is negative. Are you seeing that? So I want to make sure this region sorted, this region sorted. What about this region? When this region, we have this region, what are the values we have between minus infinity and minus 1? Number is less than minus 1. Let's talk about minus, let's pick minus 2, minus 2, minus 3, minus 4. Let's pick minus 3. That will be minus 3, right? Over minus 3 plus 1. What do we have? Minus 6 over what? Minus 2. That will become minus divided by minus, positive. What we please, these numbers are not our business. The signs are our business. So negative sign, if you put negative 2 here, negative 2, negative 3, it gives us still negative value, negative 5. So negative 2 still give us negative. So negative by negative will be positive. So this side is a positive sign. Now we go back to the question. That is greater than 0, right? If it's greater than 0, which region here satisfies when it's greater than? So that means to be positive, maybe positive sides. These are the regions that we capture that. Positive sides. See this. So here already, because it's greater than, is a strict inequality. What we should have here should be a circle, not shaded. This one too, a circle, not shaded. It is a strict inequality. This is showing that this is greater than this, and this one too is greater. You understand? So it's strict inequality without any form of shade. And this is possible. So we can write this as what is the interval? We have this interval will serve us. This interval is fine. This interval is fine. So what do we write here? We're going to be writing here, because this region comes this way. So this means x is less than minus 1, right? Or we have x is greater than 3, right? So we can combine this if we choose to combine. Or by interval, I can write that I have this minus infinity, then comma minus 1. Minus 1 is not inclusive. If minus 1 is inclusive, I will use this kind of brackets. It is not inclusive, you should know that now. So I have this parenthesis. The union of this is 3 inclusive, it is not. So we have 3, comma, infinity. You get that? So this is what we have as an answer to this question. We have solved it using this, we have solved it using this. So how do we quickly represent this? Let's represent this. We are representing this, what I'm going to add. Now this inequality will change. Let me use the same value. Let me use the same value so that we see difference in our answers. But using the same value, what are we going to be adding? We're going to be adding, of course, we have the same thing, number line, same number line. So this is negative infinity, this is positive infinity, right? And here we have minus 1, here we have 3 regions as well. But what happens is greater or equal to this. So greater or equal to 0. Now, if we are using studying this region, so here I can say if I'm having this, x can be equal to 3, so we can have this. You get? So if I have what I'm going to have in this place, yeah. So from here, when x is equal to 3, of course, you say we get the zeros, right? Because this is 0, that's why we need here, x is equal to 3. Put 3 here, you have 0. So it's possible this is greater or equal to 0. Can be equal to 0. This region 3 is inclusive. Do you understand? But for this, when x is equal to minus 1, you go into 0, you get x to minus 1. What is minus 1? Minus 1 plus 1 cannot be 0. This denominator cannot be 0. You understand? So if the denominator is 0, then it becomes undefined. So this can minus 1 cannot be inclusive. Minus 1 cannot be inclusive. Am I communicating? Minus 1 cannot be inclusive. So it cannot be shaded. Only this can be shaded. Am I communicating? Good. So we have that. So we have this now. Let's see what happens. This place is to satisfy. We have done it here. This side will be positive. This side will be negative. This side will be positive. Right? So how do we write this? What will change here is this. So here we are going to be having x is less than minus 1, or x is greater or equal to 3. Can you see this? It changed because of this equation. And here we are also going to be having here minus infinity, comma minus 1, not inclusive, union of infinity, comma 3. 3 is inclusive. Or I will write this 3, then infinity. 3 to infinity. So I have that. So this one, look at the brackets. Because this 3 is included, that's why I use this parenthesis. So this is how short and simple that can be. Thank you for joining me.